All right, good evening, everybody. Well, evening if you're on East Coast anyway. Welcome back, if you are coming back. This is the fourth installment in a series on Enterprise Node. So if you are new, welcome, and you should really check out the other three. They're not dependent upon each other, but there's definitely some things that will be talked about that are referenced in some of the other presentations, and vice versa. So tonight we're actually going to be talking about deploying with Docker, pretty much how you can do it, why you should do it. And then tonight we're actually even going to have a live demo where you'll get to see the process from code change through GitHub, through build and test, and then deploying to a registry, and then having that in turn kick off a build in Docker Cloud. So you'll pretty much get to see how you can integrate node services very quickly and deploy them in a very high velocity manner, in a really efficient manner, a way that travels very easy across environments. And we'll be discussing that in a lot more detail as we go. So this is not going to be a deep dive introduction into Docker. We will talk about some of the key parts of it, and I will provide links as usual to lots of reference materials. This is just more or less to kind of show you the power of it, but it will provide way more than enough material for you to do everything that I'm doing and run this locally. And I'm actually going to leave the service that we're going to alter and update running in Docker Cloud, and I'll be providing API endpoints that you can hit and test and stuff like that. So it'll be pretty fun. All right, so as we wait for more people to trickle in, there's two polls currently. So if you have a second and you are inclined to do so, if you could just answer those questions real quick, just helps me gauge kind of where people are at and helps me adjust content accordingly. And then also, while we wait, I guess a little bit about me. I am a tech lead at Major League Soccer. My name is Curtis Kemple. You can find me on Medium, Twitter, and GitHub. So I've been at Major League Soccer for about a year now. It's been a fantastic ride. It was really kind of the first huge jump into enterprise. We are running, anywhere about, I think, 20 different node services. We have some other services in other languages as well. We're fully containerized, so we do everything in containers. We are using Kubernetes for our deployment management, and our DevOps lead has provided us with some good modules to kind of interface with that. So as developers, it's easy for us to deploy apps. We also have tons of internal tooling and other types of UIs and applications that depend on JavaScript. So we decided to use Docker because it really helped us organize and kind of consolidate our workflow. And so now, really, no matter what project we're working on, or application or service or NPM module, or that, our workflow is so similar that it's very easy to jump from project to project. And we're able to do that by, one, using JavaScript for a lot of things, and then two, by using Docker. And because we're using Docker, we can take all of our applications and give them a very similar build, test, and deploy strategy. So when you combine these things, that actually creates a high velocity environment. So with fewer people, we're able to handle many more services. So we will be referencing code. So the repo for this webinar is in K. Kemple, Awesome Enterprise Web Service. So this is just like an example that has a lot of some of the things we've talked about around code quality, code discovery, securing your environment, in the following or the previous webinars, and then also deployment strategies for this one. So you can actually go to this repo, read the wiki, see how the project is set up. read about each part of it and kind of the thoughts behind it in the process. So we'll actually see a demo of working with this. We're going to add back a couple API endpoints later. But yeah, it's great. You can just fork it, check it out, toy around with it, and build and deploy it yourself. So it's really a great jumping off point to kind of dig into some of these practices and ideas. So the first thing that you have to ask yourself is, why would you use Docker? So like when you hear about Docker, you hear a lot about it. It sounds very unicornish, like just use Docker and all your problems will be fixed, but Docker also introduces a lot of things. So it goes from, simple deployments to Heroku, where you can just push from the command line to now you have to understand what images are and how to build and run containers and how to deploy those. So it's a bit daunting because it's kind of hard to see the benefit up front when you're looking at having to figure out a new technology and add basically a new section to your stack. So what are some of the benefits of Docker that would make you actually add that complexity? Like what's the benefit compared to the cost? So one of the best benefits to this, and one that really there's just no thing that I can think of bad about Docker or about adding that complexity that compares to this, is that you get these atomic releases. So what that means is when you deploy a Docker container, or when you package a container and turn it into an image and you store it in registry, you're actually storing the entire environment that your application needs to run, from operating system to dependencies, anything. So that means as long as you have that registry and that is backed up, you have every version of your application just stored, ready, as if it's just ready to pull off a shelf and deploy. And you can literally do that. You can just pull down any container and run it. So that alone, just giving you that artifact build that you can store and retrieve later, it makes doing things like rolling back extremely simple. Because you have these atomic releases, the entire environment is packed up. So you need to roll back. You just, you tag a new image with production, tag the previous image with production, and pull that into your production environment. So we'll talk a little bit more about that. But, that to me, that's the number one benefit. The second one is easier promotion of environments. So because everything is just perfectly wrapped up, it's very portable. So it makes it very easy to just have, wide open, staging environments or dev environments and integrate your build. So, when you commit some code to develop or to master or whatever, your Git flow is, you can just push these containers right out to the corresponding environments. And it's just very easy to say that, okay, I'm looking at this particular container on QA, it passes QA. It's very easy to say, okay, this is ready for release. So we can tag this as production, and you tag it as production and you're done. You move on. So it's just extremely easy to, just promote environments. And it's an easier continuous integration and continuous deployment process. Now, not counting ramp up learning, right? So obviously you're gonna have to get familiar with the technology, but as soon as you are, you will see that you can do so much more with your builds than you previously could, and with your whole process. It's very interesting. If I'm running a build and my tests fail, I can pull down that build container, right? That's the power of containers. I can get my app in any state and I just pull it down and I can debug it locally, or I can log into my build, SSH into a build machine and check it out there. And another thing that I love about this, and this has to do with the easier promotion of environments too, is that it enforces stateless application architectures. And so what this means is because everything is packaged and containerized, it's actually also hard to get things into an application, right? So you're not going to read config from, volume files. Generally, you want containers to be something that can scale horizontally, exponentially, right? So you start using things like environment variables for configuration, or maybe an external key value store like console. And so you start building these applications that are stateless, and so now you're getting scale, by default, just because you're using Docker. So now it doesn't guarantee great scale, but it definitely provides more scale than if your applications actually try and maintain state or a direct connection to the server that they live on. So before we dive into like continuous integration, continuous deployment, and anything more of that on doing this, I figured it'd be good if we just did a quick overview of Docker and some of the principles behind it. And I feel like that will just help guide the conversation as we go. So the way Docker actually works, actually, I'm going to share a link while I'm discussing this. This is the docs from Docker, and great information on exactly how Docker is working. So what it boils down to is you have a Docker client, and so this is like the command line app that you're running your Docker commands from, and it talks to a Docker daemon, and so that Docker daemon is running on your machine or a virtual machine, however it is you may be running it. And that daemon is responsible for Docker objects. And so Docker objects could be images, containers, volume mappings, network mappings. So anything like that, the daemon is kind of responsible for. And so then here you see that it's running on Linux, but so if you're running, if you're using let's see. So there's Docker for Mac now, which is I think what most people are using, or Docker Toolkit. There's a bunch of different ways, Docker Machine, to get Docker running on different OSs. But basically, you have your VM layer or your Linux layer, and then that's the host. And then you have a Docker client, which is your command line tools, and then they talk to the Docker internal daemon through an API. So you can actually write programs to interact with the Docker API. It's great for like doing monitoring and other types of things. So the other part of this is a Docker image, and so you can think of an image a lot like almost like if you back up your computer and it creates an image for you, which is basically just your entire operating system, all of your personal files and everything bundled up very nicely into a little package that can then be pulled out and reread at any point in time, right? Well, a Docker image is no different, except what it's building and storing is just a couple different layers. So your base image might be your operating system. So here they're using Debian. And that's one layer. And then somebody else might write a Docker file that pulls in Debian, but then they add Emacs. And then somebody else says, oh, I like that Emacs image. So they pull that in and then they add Apache, right? So that's how images are built. They work by you pull in a base image, or you just start from like as if this is a new image. So you can pull in from Node and then put your application code. So to kind of show you what that would look like, if we take a look, here's a Docker file for this project. And so we're saying we want to pull from Node, and I'm just pulling Argon, which is their latest long-term support release. So if you were in yesterday's webinar, you'll know what long-term support releases are. And then, so it's very easy. So now I'm pulling in from the Node image, and I've added these commands. And so now if somebody were to come and pull my image from Dockerhub, then they could build on top of these commands. So all of this would be included in their image, and then they could then start to build on top of that. So it's kind of like these Legos that you can assemble. So then you get up to the writable container. So that's like when you're actually writing a Docker file and you want to build from an image and you want to run your application on that image. So again, if we come back to this Docker file, this is going to create our container. This is what we're going to run in our container. This is the node image, and then this is what we'll be running as basically our image instances, and it will actually have our application. Keep going the wrong way. So I know that's a brief overview, but essentially we're gonna talk a little bit more about building containers and stuff like that. So that basically covers what Docker is and what it allows you to do. So it creates environments where you can run, complete applications, including all of their dependencies and operating system in their own private little container, and then it will help you handle communication between those containers. And we'll look at some ways to manage containers in a little bit. So now we're going to talk a little bit about continuous integration and deployments. We're just going to really discuss kind of what the idea is and what's kind of involved in it. So one part of the build, obviously, not obviously, but given the name, is you're going to want to build your containers. So the way that this works is Docker reads a project's Docker file, and then they contain essentially the blueprints for your environment. So if we go back, we know that we're going to need Node, and if we were to go and look at the Docker node file, this is what Node is pulling in, right? So when we call Node, they're actually basing from a different image, right? So they're basing from Jesse, which is like an operating system, essentially, a lighter weight one. And then so then they add Node, right? And then they export that image to Dockerhub. So you can see how like we build off of these containers essentially. And so if you want to take a look at that. Right, so then once we've provided a Docker file with the blueprint for our environment, we then build a container, right? So we take the node image, we add our stuff onto it, and then that's basically now creating a new image, right? And then when we want to run that image, that's what we're creating, a container. So a container is basically an image instance. So you build images, and then when you run them, you're running it as a container. And so when you have an image, you can build as many, start as many containers as you want from it. And images are what we pull and push from Dockerhub or any private registry, right? So an image is what you're generally working with, unless you're dealing with a running process, which is a container, right? So if we're building something, right, we're dealing with images. But if it's time now, we've pulled this image down in production, and we want to start our application. Now we're starting a container. So we're also going to talk a little bit about some of the principles behind promoting environments and some of the ways to go about it, because we're actually going to see a demo of this that will kind of bring all this stuff together full circle. But essentially, containers are stateless if they're architected properly. It's pretty hard to get them not stateless. You have to go out of your way. So they're pretty easy to deploy anywhere. So you can just run Docker pull, and give it a path to an image, and now if you have Docker installed, now you have this image. You can just start it up. You can run it. So it's not very hard to get containers. It's not very hard to store containers. So it makes promoting environments much easier because you can standardize on how you do it, right? So because it's stateless, your config is pulled from environment variables or external key value stores. So all it takes to change an environment, really, aside from maybe the server the container is living on, is you're giving it different configuration, right? So if you're running locally, you're going to give it information for maybe a local database. If you're running Docker locally, you might have, a Docker container you point it at. And if you're in production, you might have an AWS database, or you might be using, some external MongoDB service or Firebase or something like that. So you can then change these values, right? And that's your application. All it needs is this different configuration to run as if it's a different environment. And so switching environments really is as simple as switching configuration. But now we kind of need a way to say, all right, so we build this one image, and the image is fantastic. We can use it in production. We want to get it on staging. We want to test it. We still need a way to identify this image and kind of what state it's in or where it should be going. And so the way that we can do that is we can tag containers. So when you have an image, we can actually, that should be, you can tag images for environments, for deployments. I apologize. But when you have an image, when you build it, or even after you build it, you can give it tags. So you can tag it for, say, production. So this is saying under the kkemple.org on Dockerhub, find the awesome enterprise web service image with the tag production, right? And so so I can, in my production deployment scripts, or however I'm handling that, I can tell it to look for this container with this tag, but it doesn't stop there. So if I want to do QA on this container, I can give it a tag of staging, and then that would tell some build process that's watching for that tag on my Dockerhub repository to kick off some build. But you can also do it for development, and you can even tag them when you're developing on them locally, right? So I don't have to use local. I could use a Jira ticket number or my initials, and I could push this to a registry, and then any other developer can take it down and actually look at my application and help me debug it the exact way that I have it set up. It's no more, I forgot to install this module, or what version of Node are you using, or it's now everything is completely consolidated, and it makes it so easy to share. And then, so here's another great example. You've just released a production, and it turns out there's a pretty critical bug, and you need to be able to work on this quickly. As we all know, it can be quite difficult to recreate a production environment. But because we're using containers and production is nothing but configuration, we can pull down the container with the production tag to our local machines and run our production code and debug locally. So it's a very powerful solution, and this tagging helps you organize and keep track of which containers are at which state. Or which environment have been promoted to which environment. So now that we can tag them and we understand we have to build them, we need to store Docker containers. So you have a couple options. The first one is Dockerhub. So Dockerhub is basically the equivalent to GitHub, except instead of code repositories, it's Docker repositories for Docker images. So there's actually pretty much official images for almost anything that you can think of. So if you want to run Redis, you can just pull down Redis, start the container, and you're running Redis. Same goes for just about pretty much any application or service you can think of. Which is pretty great, because now this opens the door and makes it a lot easier also to test technologies. So if you're starting a new type of application and you're not really sure yet what the right architecture is for it or what the right technologies are, you can just grab a couple different Docker containers, write a couple Docker Compose files, which will help you manage that, and we'll talk about that in a minute. And you can spin up, X number of architectural choices and try them all out quickly. without having to have innate knowledge of how to set up Nginx or set up Redis or set up CouchDB or Neo4j or Node or a Ruby on Rails application. So there's Docker images for everything. I mean, there's Docker images for Chrome. You can run Chrome in a Docker image. You don't even have to install Chrome. It's like pretty crazy. People put everything into a Docker container. But yeah, so that's the number one. But again, so this is public. So anything that you just push by default is public. Now you can create private repositories just like you can on GitHub, but you have to pay. You have to have a paid account. However, on the flip side to that, much like NPM and Synapia, you can actually just install and set up your own private registry behind firewall. And great thing about it, it is a Docker container. So if you already are using Docker, you can just deploy a registry. I like to just point mine at like an S3 bucket or something, and it just throws all your images into an S3 bucket. And then now you have your own private registry running. And so obviously that's good for your actual applications, and things like that that you're deploying. And then the third option we actually talked about last night for security is Quay.io. So Quay takes a bit of a different route with both Dockerhub and a private registry. You push a built image. Quay says, hey, you don't have to build your images. Don't waste your time. We'll build them for you. And so really all they need is a Docker file. So instead of building yourself during your build process, you would kind of let Quay handle the building for you. And, depending on what you're doing with your build process, it might be a good or idea, or it might not. When we review the build process for this web service example that I have, you'll see some of the really cool things that you can do. And so I like to keep the build process internal because you can do some really neat things to test applications when they're running in Docker. So we'll take a look at that. Oh, but the reason we brought it up yesterday actually is because one great thing that Quay does offer is they'll check your images for vulnerabilities. And so this is a really great feature that, if you're pretty concerned with any type of regulations, or even maybe you're dealing with sensitive information, it's pretty easy to just check your images for vulnerabilities, and you can, prevent releases until you can do updates, et cetera, et cetera. So now we're going to take a look at some ways to manage containers. And just give me one split second. And here we go. Okay, sorry about that. So when we're talking about managing containers, the first place we have to manage them is locally. So one of the pitfalls of Docker is that it can get kind of tedious running a million Docker commands to start up containers, link containers together, getting IP addresses, and just using Docker in a way that would actually be beneficial to you, right? Like, it's very simple to use Docker for a single application, but if you're building an API, you might also need a database, or you might also need Redis, or you need some assisting services to really help you develop and test. So what Docker Compose does is basically you include a Docker Compose YAML file, and you basically give it instructions on all the different types of containers you would like to start when you run this, and how you want to link them together. It's pretty powerful, and it really makes local development a lot easier. So if let's see, start closing out some of these. Oh, this is a good one I forgot to share. So when we talk about stateless applications, Heroku wrote a really good write-up on this. Some things are Heroku specific, but most can be translated. The 12-factor app is like basically what they consider an app that is stateless, ready to be containerized, or just an artifact and scale horizontally, and just be very portable. So it's definitely worth a read. Docker file reference. So, okay, so I don't know if I shared this yet or not. I did not. So here's an actual Docker file reference, which shows you all the different kind of commands that you can do. And then, here we go. So let's circle. Sorry about that. We're going to take a look at the Docker compose file for this. So this actually doesn't, this project is, when you start it up and you're running it with Docker compose, you're actually spinning up an API, a web service, a statsd instance, a Redis cache, and a database. So anytime that I want to develop or run tests on all of this, I can now run Docker compose up, or I've even put it into a bin script to make it even easier for me. And I can spin up this infrastructure in a couple of seconds, sometimes a minute, and I can develop and test locally. I can run my full test suite against the database. I can test my statsd integration and my Redis integration. And I don't have to have these installed on my local machine. I don't have to know how to get Redis running locally. And, I don't have to set up my SQL and statsd. I don't have to understand this. I can read through the documentation on Dockerhub for these services, and generally, in most cases, you can start them pretty easily. It's fantastic. So now, when I want to develop on this API, I can actually start up, a bunch of different services. And we'll see how this can actually carry over to your deployments as well, which is pretty wild. So that's the power of Docker Compose and what it gives you. So if we want to actually take a look at an example of that. So if we come up here into a bin, so let's just take a look at starting our dev dependencies. So I'm calling Docker Compose up. This dash D just says detach. So essentially run these in the background. And then it's going to start up the database, the cache, and statsd. So now I've taken linking, or starting up 3 of these services with all of their different environment variables and all of this different stuff, and just made it something so much more manageable and shareable, right? So if we look here, like there's, if I were to try and start these containers on my own, let's just take a look at an example of a Docker run command. So this here is why Docker gets tedious. Just to run the tests with coverage, it needs access to all of these environment variables. So this is what Docker Compose is abstracting for you. It's pushing this stuff behind the scenes and saying, hey, I'll take care of all that. You just run one command, right? So if we come here to the web service, you can see here's all those environment variables there. But now I'm not having to call them each time I run it. Instead, I'm just running a Docker Compose command. Oops. Minimize that. And so if we actually wanted to do this, we could run Docker start dependencies. Right, and so that was that easy, right? So now I'm actually running statsd, I'm running a cache, and I'm running a database. So now if I do a Docker PS, we can see here that we have MySQL, we have Redis, and then now we have statsd. So now when I start developing, enlarge the font, sure. So this, it just gets the Docker text, there we go, it gets so horrible there. So we are running MySQL, now we are running Redis, and now we're running our statsd. And so I was able to start those services very easily thanks to Docker Compose. So Docker Compose is there to help you when you need to orchestrate, entire environments, actual environments like that you want to recreate, your development or your production environment locally. So again, you can see how this is very powerful. So let's say we have a production issue, right, and we can't figure it out. We can actually pull down our production database, right, like a a backup of it, load it up into a MySQL container locally, pull our production application container, and now you literally are running production, right? So, you know, and you're doing it locally. It's very powerful stuff. So another way to manage Docker containers moving away from your local machine is Docker Cloud. And so the reason I'm focusing on this in particular is because once you learn Docker Compose, making the jump to Docker Cloud is very simple. What they call a stack file .yaml is actually almost exactly like a Docker Compose file, but they just added a few extra commands that you need for actually running services in production. So if we just, okay, registry, that's Quay. I believe I thought I had Docker Cloud open here. Here we go. So this is the actual Docker Cloud account that I am running for this service, the Awesome Enterprise Web Service. And so you can see here now, just like in Docker Compose, we had a statsd, we had MySQL database, and we had a Redis cache, and then the web service. So I can create this environment, and I could have 3 of the different ones of these running with different configuration, and then I would have my dev, staging, and production environments, right? And they're all running off, you know, the same process. I deploy to them the same way. They all have their own database, their own cache, and it took no extra coding for me, right? So I didn't have to configure MySQL. I didn't have to do that. I actually just provide a stack file. And if you take a look, I know it's a bit small. Let me blow this up a little bit here so that we can see it better. But it's the exact same thing as a Docker Compose file, right? So we're just telling it pretty much the same information. So once you know one, you know them both. So it makes deploying to Docker Cloud very easy. So it's great. It's really something that's worth a look. And we're going to take a look at this a little bit later about how we kind of get continuous deployments working for our web service by taking advantage of auto redeploys. So essentially what is happening now is Docker Cloud is watching my image, the K. Kemple Awesome Enterprise Web Service latest. It's looking for the latest tag, and it's going to watch. And every time that there's a change in that repository, it's going to redeploy my containers. Oh, and fun fact, so if a container goes down, it will hold on to it for you for a while so that you can investigate it and check it out, and then you can terminate it when you're completely done with it. So we're going to look at how code gets from being committed to Docker Cloud to exposed to the public here in just a little bit. So another service that makes Docker orchestration very easy, they abstract it away and make it doable through a UI, is Rancher. So I'm not focusing on Rancher in this, I'm focusing on Docker Cloud because if you can get to understand Docker Compose, you can go right to Docker Cloud. And there's also, I've added a Docker Cloud.yaml file. Here's the Docker Compose, which is the actual stack file. So if you were to check this out and create a Docker Cloud account, you could copy this Docker Cloud file into the stack files section and deploy this exact same service. And so you can check out how to do that. So Rancher is going to do the same thing. And so this is the great thing about containers, and actually Docker Cloud does this too. So they're not actually hosting. So my containers, what they're doing for me is I actually assign a provider. And in my case, I picked DigitalOcean, but it could be AWS, it could be Google Cloud, it could be Azure, pretty much, you know, any type of provider. And then you can just spin up an environment on top of that provider very easily, and you do all of this through the UI. So I actually set up the Docker Cloud example today. I'd never used it before, and it took me about an hour, I would say, to fully understand it and have my build working to get to auto deployments. So, that's pretty good abstraction when you're considering what it's doing for you. So it's handling all the networks and the volume mapping, and so it's pretty impressive stuff. But these type of services will help you streamline it, and then the more you understand Docker and the better that you get at it, you can start to move away from these kind of platform as a service services and start looking at managing and running your own infrastructure for Docker. And so then you could be using something like Google's Kubernetes. So essentially, this is what we're running at Major League Soccer. It's very powerful, basically deployment scheduler and manager for containers. And so basically, almost like Docker Cloud, you define some Kubernetes YAML files that are its configuration, and then it will handle all the networking and port mapping and exposing the right endpoints, externally, and then you can run that on any infrastructure. So, but you're probably going to build up to something like Kubernetes. Starting with Docker Cloud is going to be a lot easier if you have minimal Docker experience. So now we're actually going to take a look at the live demo, because for something like this, it's pretty hard to just take in without actually seeing it. So we're going to actually take a look at setting up a build process. We're going to go over the build process. We're going to look at committing code. We're going to watch that build process happen. And then we're going to watch what happens in Cloud Compute when we release the service, and then we'll be able to kind of see that whole picture. So the first thing I want to bring attention to is I'm already actually running this web service. So I'm going to provide the URL. So this is my Docker Cloud instance of the awesome enterprise web service that's running, and this is the current documentation. So there's two routes that are missing from here. You can get a user's inactive tokens, and you can get their active tokens. Oh, sorry, there it is right there. Is it? Could have swore. Huh. Man, did I mess up the demo? Let's see here. 158. Master. No, we're good. I wonder if it did not deploy. We'll just run it anyway. Oh no, I did not want that. Sorry, bear with me here. This is what happens when you do live demos. Here we go, web service running. Let's just redeploy it. All right. So anyway, we really don't need that for there. But anyway, so you can look at the documentation. So what I was going to do when I added the two routes back, these two, they should not, current. Okay, so we're missing the other two routes. That's why. So we're missing users tokens active and users tokens inactive. I apologize. Okay, now it's all making sense. So, so what we're going to do is we're going to add those back, and then we're going to watch that build process, that release process, and that deployment, and then we'll be able to come here and see the documentation update and verify, in fact, that it did go out, and then we'll play around with the API a little bit. So I'm going to jump back into the code, and let's bring this up, and let's see if we can't make the font bigger. Does that look good? And then we can hide the sidebar. All right, so the code was already in here, so I'm actually just going to replace it. We're not going to do the live programming today. So we'll slap these back in. And then we'll uncomment our routes. Okay, so that takes care of that part. And now we want to take care of our tests. So here's one set. And then the next set. Okay. And we're just going to save that. This should clean up our errors. Okay. So now we have added these back, but before we commit and run the whole build process, we really want to verify, right? We want to verify, number one, that all of our tests are passing. And then we also want to verify that we did in fact add these routes back to the API. So the first thing that we're going to do is we're going to build our dev. All right, so now this is actually running a Docker build command. And so it's pulling from Node, and then it's adding these containers on top. And so what it does is it breaks your commands into other layers so that it can run faster. And so it does that so that it can cache each layer, and then it only has to rebuild as far back as you change. And since I've only changed application code, it didn't have to go very far. And so bear with me, so it's doing all NPM goodies. It's going to install everything. It's then going to compile because I'm using ES6. So it's going to run Babel on it and compile it down. I'm using actually some later ES6 features and a little bit of ES7, and they're not supported in Node version 4.2. So I still have to build down to that. All right, so everything checked out there. So again, it's just going to skip steps that it doesn't have to. And now we're building. So now it's building our source code. And so we've successfully built it, right? So now we want to run it. Run dev. All right, so it's running our migrations, and now it's running our seeds, and now it's starting the web service. All right, and so, okay. And so now we can see that we are running. Oh, and then I didn't give it the environment of local. So now we're running at this URL. Actually, we should still be good. So I should still be able to go to, let's try this, local web service documentation. And there we go. So we are now running this locally, right? So we've spun up our container, and we can see, if you look down here at the bottom, we have our new API documentation routes. So we have confirmed that the change is there, but we haven't run our tests yet. So we don't know if that is good, but we don't want to run our development database, and we don't want to run our development container. We want a clean, fresh container, a fresh database for testing. Well, Docker makes it extremely easy to do that. So we're just going to stop our dev dependencies now. And then we're going to start our test dependencies. So I've shut down my dev database, my dev Redis, and my dev statsd, just like that. And now I've started up my test database, my test Redis, and my test that. So now I want to make sure that I have the latest. So I'm going to build my test Docker container because we want to make sure that we're testing with the latest. And so this is the part, you do have to go through this again, but you would speed this up. I'm not going to go through setting up a whole development workflow, but you can actually link the code to your containers. So you wouldn't have to do this every time. I just really wanted to show you how fast it is to switch between environments and how you can actually, just build and run stuff anywhere. So. All right, and so again, just as we wait for Docker to do its thing, should wrap up relatively quickly. And the reason actually it would normally take longer, but I'm using a great package called Shrink Pack, and I talked about this last night. And so it actually didn't have to go fetch any of these modules from NPM. It actually just ran them right from, or pulled them from the project file. So what you're actually seeing is the install stuff. So this is just the install. This would actually take about twice as long to finish if we weren't using Shrink Pack. All right, so We're getting through all of this. It's quite the long build process. And so then what will happen is we're going to run our tests locally. But now that we have a database spun up, we can do integration tests. We could do full end-to-end tests, and we could do this locally. Now, normally I only go that far in building or testing during the build process. I do run unit tests locally always while I'm working, but I tend to save the heavier, slower tests for the build. If all my unit tests pass, then I'll push to the pull request, and then I'll let the build server deal with waiting on all of my end-to-end tests. It can just notify me at that point if something fails. So wow, this is taking quite a long time. It's interesting that it took longer than the dev build when they're the same thing. All right. So if it does not wrap up here in the next few seconds, we'll probably just skip the local test running part, and you can see it run during development or during the build process. This almost seems like it's in some kind of a loop. It just keeps going through post-install. Let's see what happens. Looks like it's about done now. And again, this is also because I'm putting my computer under a lot of load right now. Okay, looks like we're getting close. Oh, interesting. Look at that, invalid peer. It just ran 2 seconds ago. All right, so we are going to not deal with that right now. That's NPM fun for you right there. All right, so we're just going to take a look at our Git status. So we've changed 2 files. We'll add them. We'll commit them. We added our token routes back. We'll commit that, and we'll push it up to GitHub. We'll go hop over there. And we'll create our pull request. So this is the first part of the continuous integration. So our build now is actually running in Circle CI. So as soon as I commit, I have Circle CI set to listen for that. And then, no, we don't want master. We just want this, the demo. So first, while this is just getting set up, we're going to take a look at the Circle file and go through exactly what's going to happen during this build. So again, YAML, we're just setting up some default environment variables. And then what we're going to do is we're going to override the dependencies. So we want to build Docker containers. So we're actually going to just run Docker info, and then this will just fail if Docker is not available. So, and we can also just go back and check our build, see what version we're running, et cetera, et cetera. So this is an actual build command. So what we're saying here is we're going to actually build, and we're going to tag it as Kemple Awesome Enterprise Web Service, and we're going to attach the tag of the Circle build to it. Right, whatever the Circle build ID is, we're going to attach that. And this little dot says in the current directory. We're going to build the current directory. So now this works because Code Climate has checked out my repository. So it's basically like being in the root. So I could actually run this, pretty much same command. So if we come here, and we'll call this Outcast, right? And specify that. And so when I run this, it's actually going to start running and building my Docker container. So that's the actual build command step. So next, we actually want to test it. So the first thing we're going to do is run this container, and we're actually testing it to run our audit. And so the npm audit command that I wrote, it's running the node security project vulnerabilities check. So first we want to test for that. I added this part here. It really shouldn't be here, but just so that the build would continue, so that I could show you, because there's vulnerability issues in there right now, and we'll look at that I just don't have time to go in and fix at the moment. So then the next thing we want to do is, if we're on the master branch, we're going to run our container, and we're going to give it all the environment variables it needs, and we're going to run our test, but we're going to run the coverage version. So we're only doing that for master because we just want to check the coverage of master branch. And if you were around for the webinar on code quality, you'll understand why we test for the coverage and why it's important. But we only do it for master because you really only want to store what the coverage is for the actual code that is, releasable or ready to go. But if it's not master, then we're just going to run our tests, but we're not going to run coverage, right? So it's the same command essentially, just we don't want the coverage. So, but here's where it starts to get fun. So if we have this Docker container that we can just run our tests in and stuff like that, and that's pretty normal for a build. But here's where it starts to get different when we're using Docker. So what I can actually do now is I'm actually starting the container, and I'm setting it to sleep for 10 seconds. That gives it long enough to make sure that it's set up, right? And so then once I know that it's started, I can then add a test step where I'm actually hitting the running container. So I'm actually curling to it and testing the health check endpoint of this container in my build during my build process to make sure it can start up and accept requests. So you can do this before you've even passed your build, right? So this is great. If this fails, there might be times when you get through all of your tests, but because you haven't actually started the server for that, there might be something that you miss, something that's just not, something that's amiss. And so then you might catch it here because it'll fail the health check. And so, a health check is a common practice that's used by load balancers and other application monitoring services to test whether or not your application is up and able to receive requests. Sometimes it'll be called status, sometimes it's health check, but essentially that's what it boils down to. And in enterprise, when you tend to have deep monitoring integration, and as a matter of fact, Kubernetes uses this, AWS load balancers will use an endpoint you specify to test for your health. So it's pretty common practice. And so then this way we can say, hey, if we release this container, it's going to pass a health check, so it's ready to run. And then if we're on master, we want to deploy. And so here we're saying hub, which is equivalent to Dockerhub. And this is a Circle CI specific thing, right? But then we're just logging in. And the first thing that we're doing is we're pushing the container that we built. So we're pushing the one that we've built and we just run, because we want to be able to track every tag. We want to be able to go back to any tag and grab it. But in our case, since we're on master and we want to do continuous delivery and continuous deployment, I'm going to build again. And this one will go very quick because all the layers are cached and nothing has changed. So it'll just take a second. And I'm going to tag it with the latest. And then I'm also going to push that latest, because this latest will get overwritten from each master build, but will always still have a reference to each particular build, right? And so that's important. That's how we get that atomic release. So now I can always go to my registry. And as a matter of fact, if we take a look at an example of this, this Docker Cloud, I believe I had Dockerhub open here somewhere. We'll just open it. Hub.docker. When we open this up, I can go to tags, and so we see we have latest, right? And so this will always only be one, right? Because we're going to overwrite that with each build. But then we have all of my tagged images. So I can come here, and this is from every Circle CI build, right? So everyone that's master and has passed and been deployed is here. So I can pull any one of those down to my local machine and run it. And I can get nostalgic and run one, when I just added a couple endpoints. and pull it down and run it. So it's pretty powerful, right? So now I have my application in every state that it's ever been in, at my fingertips, one Docker pull away. And so that's what we want to do. So now that we've had a chance to see that and we can see the build pass, let's take a look at what it looks like in Circle CI. So I'm going to try and blow this up a little bit. So that's a little more readable. And we're going to come down here. So this is where it's starting and setting up and exporting our environment and variables. Where it really starts to pick up here is where we defined these commands like Docker info, right? So you can see, it gives me a bunch of information, which may help me debug if there's an issue and my containers fail to build. And then here we're building, right? So the same command that we ran from the command line, which finished successfully, which is odd because that test one did not, right? So that's very odd. Sometimes NPM just fails on you. Oh wait, well, the NPM install, because we didn't fetch, so I can't blame it on that. So this is where we're actually building, and you can see that we pretty much have the same output. I'm not going to scroll through that. It'll take forever. Right, and so then it's going to save cache, right? We're going to start up and run our audit. So this is cool. I also showed this yesterday, so I just want to showcase this. Checking your dependencies in your modules for vulnerabilities is pretty important. So it gets overlooked a lot in Node. It's way more common practice to do this in like Ruby and PHP and other languages. You'll see this as part of the build process. People, it will fail if there's vulnerabilities found. It will fail the build. But you can do this in Node, and you should, maybe even more than other languages at this point, because it's so much more popular, which means a lot more people are going to be targeting Node when they're trying to, do deviant acts. So as you can look here, so I said this last night too, I just updated the vulnerabilities and my dependencies 2 weeks ago, maybe 3 weeks ago, and already there's seven vulnerabilities that are here now. And so it's going to tell me, where it's coming from and everything like that. All right, so I didn't want to waste too much time on this part, but so you can see that here that this was not master, right? So it's just going to skip this step. So we would have run our regular tests right here, and yep, so we can see that we ran ESLint, and we're running all of our entire test suite against the database. And so we have like, some odd 70 tests ran, and then here's our local coverage summary. We just don't send it off because we're not on master. And so now we know it's good. So then we started it, and it started up okay, and we got through that. And then we hit the API health check, and we got through that. And so everything was good, and all was well in the world of this build. So now we can go back to GitHub, and we can merge this pull request because everything is checking out, right? So show all of our checks, our build passed, found no style issues. So we're just going to go ahead and merge that, right? So now we're done. So we're going to get another build now, right? So now it's going to build off the master, but this time we want to look at something different. So Circle CI is freezing on me. So this is running. So the important part that we want to watch for here is once we're done with the testing and everything is done and we deploy, we're going to jump over to Docker Cloud, because once we push to the registry and we've tagged with latest, Docker Cloud is going to pick that up, and it's going to redeploy our image, and then we'll actually see these endpoints update. So here we are on the actual web service endpoint. If we refresh, we still don't have those endpoints yet, but we will once this gets deployed. So we will wait patiently for the build. So while we are waiting for the build, I have actually compiled here a couple queries that you can send against that API that is running to just kind of test it out. If you want to test out like the authentication and authorization stuff that we talked about last night, I just wanted to mess around with it. So I'm not persisting the data. So when we redeploy, it will remove any data that you add if you add any users or anything, but feel free to check that out, and then you can send some requests. So you can see here it has like the body content as well. So if you want to send some stuff, feel free. And one cool thing you can do, so one thing I wanted to show is that we were talking about JSON web tokens last night, and here is one right here. And I'm just, sorry, I'm going to check the build because I don't want to miss when we, okay. So there, I just don't want to miss when we redeploy automatically. Okay, so we were talking about JSON web tokens and how they're great because you can store information for them and they're secure. And I was talking about this JSON web token debugger that you can test out, and this is pretty cool. And I just want to showcase it because we can actually take these tokens, and I just have the secret set as secret, so we don't have to change anything. And I can drop it in here. And cool. So this is the actual payload data that would go to a client and be attached to that JSON web token. So we have a unique way to identify the token, and then we just send the email and what their role is and their ID. So if you are messing with the API and you were interested in the JSON web token discussion from yesterday, this is a fun way to go ahead and play around with it. You could create some new users, authenticate them in the API, and then just take a look at the tokens. And then also, let me check this build again. So how are we looking here? Okay, great. So it is running the tests. Yep. All right. So we're running tests. So we're getting close. But yeah, so as I was saying, if you go to the wiki here in this, it has setup instructions for the application, how those JSON web tokens are being generated, how all of that is configured, and all of it can be found here. So you can actually build this application, pull it down, mess with it. And then also there's a Gitter chat. So, if you pull it down and you start messing around with it, just jump on Gitter. And as soon as I get a chance, I'll be around to help you out. All right, so let's check this build again. Okay, all right, cool. So here we go. So we're doing our first Docker push, which is we're just pushing the tagged version right now. So this is not going to kick off our deployment process. 8:37, cutting it close, but we're almost done here. Here we go. Come on. Let's go circle CI. And then this is the hard part of Docker, waiting on the builds. Yeah, but I do strongly encourage, oh, here we go. So now we're building latest, and this step's going to go really quick, right? We're just flying right through it. Everything's cached. Don't mind this guy here. That's a Circle CI specific thing, that error. It's not a real error. False alarm. All right, so this is going to build, and then it's going to push, and then we should see some deployment action. All right, so we can actually watch for this update. Here we go, sorry. So now we're pushing the latest. So now if we jump over here to Dockerhub and we go to the web service, we're gonna check out the timeline, and we're just gonna sit here and wait for a second. Oh, there we go. Service redeploy, auto redeploy on push. So now that my build has completed over here and pushed, as soon as that happened, Docker Cloud picked it up, and now it's redeploying my application, right? So no hands on me. All I did was merge a pull request, and this container is going to be released into production. And then when that's done, we can monitor that. So if we just come back here to services, we can see that it's redeploying. It's in a state of redeploying. Or if we come here to our stack overview, jump in here, we get a nice little overview. Oh, so, okay. Well, let's see. I think it's still redeploying, but it's showing it is up. No, it's already done. So now this web service is done. So theoretically, we should have some new documentation. Hey, and so there we go. So now we've added 2 new routes. just like that. They're showing up in our docs, our live documentation. And we have continuously built, tested, deployed a Docker container. So with that, that's going to bring us to Q&A. So if anybody has any questions, I know that's pretty deep content, but if you have any questions, feel free to throw them out here now. Also, you don't have to answer right here, right now. Feel free to jump on Gitter, and you can ask me questions there through that awesome enterprise web service chat room. You can also find me on Twitter and ask me questions there at Curtis Kemple. And if you have any questions, please reach out. So while we're waiting on that, this was the fourth part of a series in Enterprise Node. The first one covered code quality, second one covered code discovery, and then the third one was about securing your environment. And then this fourth one kind of helped wrap up all those processes. So we see how all these different things come together to help you build these streamlined processes for building, testing, and deploying applications. And then also, I'm going to be talking about this as well at O'Reilly Software Architecture Conference coming up in November. So I'll be doing a 90-minute session on architecting for enterprise and Node. So it covers much of the same content, but it's going to try and pull those pieces together a lot more mainstream. Here they were broken up over 4 longer individual ones. This one is going to kind of give you a smooth flow through most of the JavaScript stack, like anywhere on the stack. So it'll be a very interesting time. You should come and check it out. And with that, that is it. So I'm going to just hang out for another minute, see if any questions roll in. If not, we will call it a wrap. But actually, I'm going to add a poll real quick that I forgot to add, and love it if you guys could fill it out as soon as it pops up. Second. Oh. Yeah, so if you could just let me know how you thought it was, how it went. I would love your feedback. You can give me feedback on Twitter. Reach out. Again, you can catch me on Gitter. Yeah, I would love to know how you guys thought about that. I'd love to hear if you're using Docker in different ways or any types of services or tools that you might know of. I'm always on the hunt for good technology. But with that, I think we're going to wrap it up here. You guys have a great night. It's been a pleasure doing this webinar series with you. And, maybe we'll do some more here in the near future. All right. Have a good night.